Every time you open a video, send a message, or search for something online, a request leaves your phone, travels across the world, and returns in under a second. But where does it go? That's what we're going to find out. A data center is, at its core, a warehouse full of computers. Not consumer computers, specialized ones called servers. A single modern data center can contain tens of thousands of them, stacked in tall metal cabinets called racks, arranged in long parallel rows. Every major website, app, and streaming service you use runs on servers in facilities like these: Netflix, Instagram, Gmail, Spotify. When you use any of them, you're connecting to a data center. So what actually happens when you make a request? Let's say you tap a YouTube video. Your phone sends a signal, a packet of data, out to the nearest cell tower or Wi-Fi router. From there, it travels through fiber optic cables, moving at close to the speed of light, to a data center that might be in Virginia, Iowa, or Oregon. Inside, a server receives your request and begins pulling together the video file associated with it. The server breaks the video into small chunks and sends them back the same way they came, through cables, towers, and finally into your phone, where they're reassembled and played back. All of this happens in under a second, but servers can't just run on their own. They need a few key things to keep going. Power, lots of it. A large data center can consume as much electricity as a mid-sized city. Most facilities have multiple power feeds from the local grid, plus backup diesel generators for outages and banks of batteries to bridge the gap if grid power drops for even a fraction of a second. The goal is 5 nines uptime, 99.999% availability, which means less than 6 minutes of downtime per year. Then there's cooling. Servers generate enormous amounts of heat. If that heat isn't removed constantly, the hardware fails. Data centers address this with precision air conditioning systems. Cold air flows in from below, passes through the server racks, and exits as warm air from the top, where it's collected, cooled, and recirculated. Some of the most efficient facilities use outside air or even bodies of water for cooling. Microsoft famously sank a data center pod on the seafloor off the coast of Scotland. Finally, networking. Every server needs to be connected to each other and to the outside internet. Data centers are wired with thousands of miles of fiber optic cable internally, and they connect to the wider internet through relationships with internet exchange points and backbone providers. When your data request arrives, it's routed to exactly the right server, processed, and sent back, often all within 20 to 50 milliseconds. Data centers are essentially the physical infrastructure of the modern internet. We think of the cloud as something intangible, but it has a very specific address, a zip code, a building, a room full of humming machines behind locked doors. They're also one of the fastest growing types of infrastructure on the planet right now. AI is driving a massive expansion. Training a large language model requires enormous amounts of compute, and that compute lives in data centers. Companies like Microsoft, Google, and Amazon are spending hundreds of billions of dollars building new facilities worldwide. And while you'll almost never see inside one, most are in industrial areas with no signage. These buildings are quietly running nearly every digital interaction in your life. So the next time something loads on your phone, a video, a message, a search result, there's a building somewhere that made that happen, full of servers, cooled air, backup power, and miles of cable. The cloud has an address, and now you know what's inside it. If you want to go deeper on any part of this, how the internet itself routes data, how GPS works, or how the electrical grid delivers power, those are all coming up. Subscribe so you don't miss them.